Hi, students and family members. This is Mr. Panza. Today's focus question is, how do we use concrete objects to help us understand fractions? We're going to focus on the CRA method, specifically the concrete portion, to understand fractions. The first example we'll go over are adding fractions with uncommon denominators using concrete objects like the chips you'll see on the screen behind you. Our example is 1/2 plus 1/7, both unit fractions, both that can be represented using the count and size method in the concrete model. So let's go over to our chipboard here and explain what we have. So we know that it's 1/2 plus 1/7, which looks like this. We also know that we cannot add, subtract, or compare fractions with uncommon denominators, or the size cannot be different. In this case, the size is different. We have a denominator of 2 over in this chip count and a denominator of 7 in this chip count. So we have to come up with an equivalent fraction. In order to do that, you can look back at the original problem and look at the size and multiply them together. 2 times 7 will give me 14. That will be my new denominator for each of these. Or just simply create 7 groups of 2 to create an equivalent fraction over here. So let's go ahead and do that. Here's my first group of 2, and I'm going to create a second group of 2, a third group of 2. Oops, I switched up the colors there. Easily changed by flipping the coins. There's my third group of 2. Notice that each time I create another one, I'm making sure that, for equivalency's sake, I'm still making it 1/2. One is yellow and the second one is red. My count is yellow, and my size remains red. So there's my fourth group of 2. Fifth group of 2. Sixth group of 2. And seventh group of 2. And to make sure that everything is equivalent, each of these groups of 2 has to have the count of 1 out of 2, which are yellow, because remember, the original fraction was 1/2. In order to change this to a common denominator, needs to become 14, or I need 2 groups of 14. And that's because when you look back at the original problem, if I multiply the denominator, the size, by 2, I'm going to get 14. So I can do that just by creating a second group of 7. There's my third row, 4th, 5th, 6th, and 7th. And making sure that everything's equivalent, I must flip that top one. So you can now see that 1/7 is actually equal to 2 out of a total 14, because one group out of 2, 3, 4, 5, 6, 7 are yellow, or 2 individual chips out of a total 14. And in this case, 1/2 or yellow, or you can look at the other way where you have 7 of the individual chips out of 14. But the denominators are now the same, and you can add these moving forward. Let me show you how. On my original problem, I showed what I did concretely by multiplying my numerator and denominator by 7, which gives me 7/14, which you can see over here, 7/14. And in my other piece, I multiplied my original numerator and denominator by 2, which gave me 2/14. A common denominator of 14 means I can now add these together. The way you add these chips are by taking this chip, putting it over here. You cannot simply take a chip and move it, because now all of a sudden I don't have 14 anymore. I have 13, and the denominator cannot change. And I can't just take this chip and move it over here, because now I have 15 over here and 13 over there. Instead, you're going to take your chips and flip them to add them together, and now you'll see that when you add 7 plus 2, you have 9, and the denominator did not change, so I have 9/14. When added together, 1/2 plus 1/7 is actually equal to 9/14. That's how you add fractions with uncommon denominators using this concrete method to help understand how it all works. let's move on to example 2. In our second example, we are going to compare fractions with uncommon denominators. In this example, you see 3/5 and 2/3. And I have the chips lined out with the total size of each. Now I need to count 3 out of these 5 to show the numerator. So this is now 3/5, and my size, which over here is 3, needs to be counted as 2/3. So 2 of the 3 are the ones that I'm counting. The problem with this is the fact that they're uncommon, and I cannot compare, add, or subtract fractions if they have uncommon denominators. So if I look back at the original problem again, I can create equivalency by looking at the denominators, multiplying 5 times 3, which is going to get me a common denominator of 15. Or in other words, I need to create 3 groups of 5 and 5 groups of 3 for each of the opposite fractions. Let's start by creating 3 groups of 5. So over here, I have 1 group of 5. I'm going to create a second group of 5. And a third group of 5. And because I'm creating this concrete model, I want to make sure, for equivalency's sake, that the counts remain the same. My original fraction was 3/5, so every single one of these needs to match for equivalency. So now you can see that 3/5 is also equal to the original 3 groups here out of 5, or in this case, 9 out of 15, a total of 15. I then have to look over here and create 5 groups of 3. So I have 1 group of 3. Let's do my second group of 3. Third group of 3. Fourth group of 3. And fifth group of 3. And for equivalency purposes, yet again, go look at the count. It was 2 out of every 3 that needs to be flipped. Which you can hopefully see I have 2 groups of 3 that are yellow, or if I count them all, 2, 4, 6, 8, 10 of a total 15 in size, because that's equivalency. Let me show you what that looks like in the original math problem. So in the original problem, I had 3/5, which we had over here, which 3 groups of 5, when multiplied by 3, is equivalent to 9 individual chips out of 15. 9/15 is the equivalent fraction of 3/5. We did the same thing to this fraction over here. It was originally 2/3, 2 of the 3, and I still have 2 groups of 3 that are shaded in yellow, but now when I count each individual chip, 6 of them, 1, 2, 3, 4, sorry, I made a math error here. And you can see I magically changed that math error. I should have multiplied by 5. That's the nice thing about the CRA model. I would have probably got it wrong if I just jumped right to trying to do this mathematically. Instead, when I'm double checking with my chips, I realized I didn't have the right response, and I would have had the incorrect answer. So instead, when I checked my response and I said, no, I should have been multiplying by 5, not 3, I double checked it and I can see, oh, that's right, because now I have 2 groups of 3, or when I add them all together, that's 10 out of 15, which matches as an equivalent fraction here. And now because the denominators are equivalent, they both have 15 total chips, I can compare the counts. Which one is greater, 10 or 9? In this case, 10/15 is greater than 9/15. So when I go back to the original problem, 2/3 must be greater than 3/5. So my greater than symbol will open towards the 2/3, and it is read as 3/5 is less than 2/3. I hope that seeing this in the CRA model helps you understand how you can understand and answer fraction problems using concrete representation.